Hello and welcome back to the development of the Feersum Scheme compiler. Right, so I'm going to start by going over what went on in the last stream, and then we'll have a look at what we're doing today, which is going to be hopefully all about captures in our Lambda implementation. So in the last stream we worked in the binder to allow references to identifiers that were defined in parent scopes. So the way we did that was in the bind, when we look up a binding, if we find it in the current scope, we directly return the value. But if we couldn't find it in the current scope, we recursed into the parent and called try find binding. And this means that if you define a lambda inside the body of the lambda, you could see all of the global variables and you could see all of the built-in functions and things like that. And it allowed writing things like it was in the comments extended scheme. It allowed writing things like this, where in this case the initial problem was that we had to define all of these, and we had to redefine the operators and the fact symbol and things like that to make this even compile. But in the end, we were able to actually write a version of fact that worked. So in this case, the multiply, minus, equals are all looked up in the parent scope, and that's fine because they are built-ins. And in this case, fact is actually a global because it's defined in the root scope. And as long as the things you're looking up from parent environments are global or can be viewed globally, everything is okay. So the plan for today is to look at what happens when you capture something, well, to look at what happens when you reference something from an inner scope that isn't a global value. So I'm going to begin by writing another version of the factorial function, but this one is iterative. So the original definition of factorial was recursive. So if we call fact, it either returns the results or it recurses into factorial again, which can be, I mean, there can be performance problems associated with recursion. I mean, in a scheme, we're supposed to have tail recursion. That's a pretty acceptable way to write the factorial function, but we're not actually properly tail calling here. So ideally what we want is the recursive call to be the last thing that's executed by this whole lambda definition. So what we can do is we can define iterfact n, and the way iterfact n works is it defines another lambda, iterfact with accumulator, which takes n and an accumulator, and then in there we do if n is 0, we return the accumulator, and if n is not 0, we call iterfact with accumulator again, recursing with n minus 1 as our n, but we also, instead of doing the multiplication outside the recursive call, we do it beforehand before we recurse down into the next level. And hopefully that should also be 24. I'm just going to get rid of the original definition of fact. Actually, no, I'll leave it in. So if I run the compiler against that, we end up with an exception at compile time. And if you have a look up at the top of the stack, the problem is argument out of range exception. And it is because when we are trying to emit the call up here, we're finding the way this will get lowered is that we define a global function which has one parameter and one local, and this one's to actually be iterfact with n and 0 as the accumulator. No, 1 is the accumulator. Yeah. The way this works is that we will have one local variable called iterfact with accumulator, and when we call it here, everything is okay because we can see the local variable. But when we call it from within iterfact, the way that the scopes work in Scheme is that this lambda is actually defined in the scope of the iterfact function. And so when it wants to call itself, it actually has to look itself up in the parent environment. And so the way that our current binder handles that is it will walk up those tree of environments and it will go, that is the first local. And so it tells it to load the first local. But within this lambda, there is no first local. And even if there was a first local, it would be telling it to load the wrong thing. So that's why we're getting the argument out of range exception. What we need to happen in that case is when we walk up to the scope of iterfact and we see a local variable, we need to capture that variable, which means take a reference to that variable, move it into some storage that can live longer than the call to iterfact itself, and we return some kind of reference to that captured value so that the inner functions can read and write from that shared variable. And then after we've done that capture, we need further references to iterfact from inside, so iterfact with the accumulator from inside the outer lambda to also resolve to that same place. So I'm going to try and do some drawings here to hopefully make it a little bit clearer what's going on. So the way this is working is you start off and you have the scope of iterfact, and inside there we have n, which is arg0, and we have the iterfact accumulator, which is local 0. And then inside inside iterfact with accumulator, we have n, which is arg0. We have ac, which is arg1. And then we don't have any locals. And so what we want to happen is that if we have a binder, we have two binders effectively. So the first binder is out here. I'll just call these binder and binder. In the inner binder, when we try and look up a value, and we start off, we look at, so if someone references iterfact with accumulator, we look there and it isn't there, and then we look in the outer scope and we find it. We need to do something to this value, and effectively that is called capturing. So the way it's going to work is that we at the moment have two places for storage. We have arguments or locals, but what it's going to happen is we'll have a third place, which will be the environment. So when that gets captured, we'll say this is actually in the environment, and then there is a pointer. This is difficult to explain. To the environment. And like at index 0, we have that iterate. And so instead of trying to reference it in the outside environment like that, we go and read it from this shared environment structure. But the other thing that we need to do is we need to keep track of the fact that we've moved the value into the environment, so that when we continue to reference it from inside, we still get the same value, because we don't want to be having the original lambda reading and writing from the local argument or the argument, but any lambdas that have captured it reading and writing from it in the environment. The way I'm planning on doing this is having environments represented as classes, and then lambdas can read and write from the environment by lambdas being instance methods on that class. And so we'll have a look at that in a bit. The first place to go is we're going to have a look adding storage types for our captured values. So in the bind, we have the storage ref type, which is effectively our representation of where a value could be stored. It's our reference to a storage location. So the storage locations we support are arguments at some index into the arguments array, globals at some named place on the root, locals at some index into the locals, and built-ins which are named as well. So what we want to do is add a new location for storing things. So the two new places that we could store things are environment, and I'm going to make the environment an int, which is the slot it is within the environment. And then I also think it might be useful to have the original storage that we've captured into that. So we'll keep track of that as well. And then the other place we could have stored stuff is captured. And if we have a captured value, it means we're not in our current environment, we're in the outer environment. So a captured is just going to be a pointer to another storage location. And the way that capturing things several layers up through the like stack of scopes will work is that we'll just have a chain, we'll have a linked list of these captured values. So let's run the tests and see how it goes. Snapshot not existing. Now, since the last stream, I've also added a new task. Not run test task. I've added a new task for updating the snapshots, so I don't have to go and set the attribute and then run the tests. So hopefully that should mean that, yeah, now we've got one failure, which is the fact that we can't compile this itafact example. Good. I'm just going to delete that. I've also added support for specifying the output path on the compiler, so all of the binaries are no longer littered in the specs folder. They're now in the binaries folder, which is a lot cleaner. No one wants to open an exe directly. Right. So now we've added in a new location that we could store things. The compiler and the interpreter are going to complain. Effectively, the interpreter is abandoned now. So what I'm going to do is just add a catch-all here, really. And just fail with storage not supported. Let's do that. I will get round to removing the interpreter at some point. There is also another reference, which will be when we try and load from it. Yep. Let's just do storage not supported again. Good. So the interpreter is at least happy, and the other place is inside our compiler. So our compiler, when we try and read and write from those storage locations, we need to know what opcodes to emit for that. And I'm going to defer this problem for a little bit. So when we get an environment, it's going to have the index and it's going to have the captured storage location, which we don't need. So to store, at the moment, I'm going to do a no op and add a to do comment, because we haven't yet defined the environment type or anything, so we have no way of storing values here yet. Wait, it should be a fix me. Need to store into the captured environment. And when we do a load, we need to produce a value. So in the load case, I'm gonna do load from the captured environment, but this is going to be load null for the time being. So any attempt to read from the environment or write to the environment is effectively not going to do anything interesting, because we haven't actually created the type for our environment yet, but we do want to at least stub out these cases correctly, so the compiler at least compiles. So if we get a capture, again, we're going to have well, I mean, we could call it captured from, couldn't we? Because this is the storage location that it is being captured from. Again, so we need to walk up the capture chain in this case. And the same thing down here. If we get a reference to a captured value, we need to load from the captured environment, and in this case it is again going to be a load null. The difference between these two here being that if we have a storage ref environment, we're reading and writing directly from the current lambda's environment object. But if we get a storage ref captured, we're going to have to emit some kind of sequence of indirections to look up the parent environment and then potentially the parent and so on and so forth, until we've walked far enough up the chain that we can then effectively do the same sequence of instructions that the storage ref environment would do, and load it out of the environment object. So now the compiler should compile again. The test's still going to fail though, but we can check off the first low-hanging fruit to do list item. Let's start staging some of this stuff. And adding the bound value, yep. Actually, I'm gonna commit just the interpreter as catch all failure. Right. So while we've got those storage locations, we need to actually do something useful with them in the binder. So the way that the bind ident works at the moment is we call binder context try find binding. So this is the only place that this is when we look up an identifier to try and load from it. And if we have a look at try find binding, there's the only place that we access the binding is when we try and read from it. We also, I think we also do try bind ident when we try and write to the identifier. Yes, we do. So we call bind ident and then either call a load from it or if someone calls define, we will call bind indent and then store to it. Where's the define? Whenever you call bind, whenever you call define, you must be introducing a new local, so there's no need to look it up from the environment. That makes sense. So we can do all of the changes within this try find binding. So effectively what we've got is when we call try find binding, we're returning the storage from the current scope, and then we've got this parent lookup. So the first thing I'm going to do is I'm going to extract the parent lookup into its own function. Now the parent lookup is mutually recursive, so does this need to be well, we're going to have a second kind of lookup where we also capture the value. So I think we might actually be okay. We might not have to make these all mutually recursive. But we'll see. This will be recursive though. So this is the case where you're trying to look up a value inside a parent context, which I can make private. In that case, we just want to do this option bind stuff. So the context, well, we'll just do a match on the context because we're not going to know here whether or not we actually have a value or not. And if we do, then we'll do a capture of the value, and if we haven't got if we couldn't find a parent, then we'll just return none. I'm not using option bind here because we're going to do something more complex in here. As I say, we're going to do a capture lookup. So I'm going to introduce another function to do the capture lookup. In this context, in the parent for this ID, which is again going to return sum if it manages to capture that value and move it into the environment storage. And if it does that, we will return a storage reference captured to it. And if it returns nothing, we're going to return none again. And then this, I think, wants to be mutually recursive with lookup and capture. So in this case, oh, that needs to be some. We're going to effectively do the same kind of thing that we did here in the plain lookup. So we're going to fall back to a parent lookup. Parent lookup. What is it complaining about? All branches. This is a branch of. Oh, yes. We actually need to pass the ID in that we're going to try and look up. In the case where we do find a value, we want to handle moving this value into a new storage location. So what we can do right now is we can do scope is gonna be storage ref. Well, we'll define a variable for our captured value. It's going to be an environment reference. We need to give it an index into the environment, which means that we need to keep track of what the next environment index is. But for the time being, we can just give it 0. And then we'll give it the value that we've captured. So that's where the original storage reference was. And then we'll return some of our new captured storage reference. So that's going to work if we find the value in the environment and it needs to be captured. And the last case that we want to handle is that we find the value in the environment and the value is already a captured value. It's already in the environment. And if it's already in the environment, we just want to return it. I'm wondering whether or not we can just take the ID and original location and just reconstruct. So if we've already moved it to the environment, we'll leave it where it is. If we haven't, then we create some environment location for it, and then we need to keep track of that in the scope. What's going wrong here? Ah, yes, it needs to be an assignment. Context.scope. Good. And that means we also need to do get next env slot context. So we'll get this. Effectively, it's going to be, the environment's going to be another array. So we will have just a counter on the binder context that keeps track of what the next env slot is. And we just need to assign that again. And return the original. So we need to add a next env slot, which is mutable. And it's going to just be a plain identifier. We're going to start that off at 0 in both cases when you've got an empty environment, or when you're capturing an environment in a Lambda. So that's looking quite a lot like it actually compiles. So hopefully this test shouldn't throw an argument out of range exception anymore, because when we try and bind the identifier, we should do this parent lookup. The parent lookup should effectively, the parent lookup should look up and capture it in the current environment, and then we should get a captured pointer back to it, I think. Right, let's try that. That's made things worse. What has gone wrong? Snapshot does not exist for it fact. Yes, that's because the compiler is now passing and emitting a bunch of load nulls and things. So that's correct. Fact.scheme is now 134, means that there was an uncaught exception when .NET executed the program. So locals and fact are now throwing. So let's have a look and find out why. I'm going to take a look at the IL that's been generated for the locals. So that's going to be in the spec bin locals. Now, and we could probably do with having a look at the locals scheme itself. Right, so I think I know what's happening here. What's happening is we are being a bit overzealous with what we capture. What we want to do here is that when we call parent lookup, if the value doesn't need to be captured, we won't capture it. So if the value is in the environment, I think there's going to be a lot of cases where we just want to return the original value here. So if we have a look at what the types of value are that we want to capture, we will, if the values if the value is a local, or the value is an argument, what's an argument called? An arg. Then we want to capture it. So then we do this where we allocate a new environment slot, we create the captured storage reference, we store it back into the scope. Can we set value? We'll return value in that. No, we'll return sum of the captured in that case, yeah. But in the other cases where it isn't a local or an argument, we can just pass it straight back up. So this is the case where you found something that's in the global environment, or you found something that's a built-in. And in the parent lookup case, what we need to do is take a look at what we've got. So if it is, if we've found some upper value, what we need to do is decide whether or not we want to recapture that. So I'm just going to rename this to outer, because if it is a captured value, or it is an environment value, then we're going to recapture it. So this will allow us to keep track of how far up the chain we need to go. And in the other cases, we will just return some of the outer again. Right. Hopefully, we shouldn't end up with quite as many test failures now. One test failure. Good. And why has it failed? A snapshot did not exist. So if I tell it to update the snapshots, this will at least appear to work. Oh dear. Maybe I was being a little bit... Oh no, it's run all of the tests. But I think some of them have thrown an exception. Probably we are trying to yeah, 134. So we're getting an exception from that test case, because if we try and execute it, we will throw a null reference exception when we try and jump into the null value we loaded onto the stack. So in its effect, yep, in lambda 1 we're getting a null reference exception, but we are at least binding things correctly. Right, so we've got the right capturing going on, but to be able to do anything with it, what happens is when we call bind lambda, we call bind named lambda. No. Bind lambda body, but where does that get called from? We call it from define and lambda. So what we want is that the body of a lambda at the moment is body of a lambda at the moment is a bound expression of lambda. So we've bound the sequence for the body, we've bound the formal parameters, and we keep track of how many locals there are. So a lambda also needs to keep track of what enough to allow for the creating of the environment structures. So effectively what we need to know is when we get in the compiler, when we do emit named lambda, we emit, well, sorry, actually when we call emit lambda itself, we're effectively loading a value onto the stack. But what we want to do is also move anything that lambda captured into the environment if it isn't in the environment already. So that means that emit lambda creates the actual the pair of functions, the real function thunk, and it calls emit method to func. But before it does that, what it effectively needs to do is walk through something and move everything into the captures environment. Obviously we can't do that right now because we don't actually have the environment type yet, and we don't have enough information in the lambda itself. Like, we've got the formal parameters in our locals list, but we don't know what this lambda has captured. So we don't know at the point when we're doing the compilation emit what we do need to move into that environment. And yeah. So what we need to do is, in the binder, we need to add another element to the named lambda, which is going to be a list of storage locations that it has captured. When we create that, we need to add in that list from somewhere. So we create the lambda context, and what we want to do is build up a list on the context of the captured values. Yeah. Call it captures in there. When we create the new environments, we start off with an empty list. That's going to be captures, and that's going to be captures. And I think try and work out whether or not there's enough shared code now between the create scope with parent and the create for global scope to justify actually unifying them, but I'm not going to do that yet. So now we've got the captures list. We need to keep track of every time we move something into the captures environment. So that's every time we call parent lookup and we return some captured value effectively. So in here we will do context, no, parent, is going to be so if I have a look at the compiler, hopefully I can put a breakpoint here and try and run the compiler against the its effect. We should see it actually capturing some values. So let's go edit the Feersum. So if we run the compiler and we tell it to go to spec, and we tell it to output to bin. We can launch that. That didn't hit the breakpoint because I got the command line arguments wrong. After all of the other arguments, fair enough. I think that's something that could be turned off actually in the argument parsing library that I'm using, but it's not the worst thing. Right, so what lambda are we emitting here? We are emitting I think this is going to be the outer lambda. Yeah, so the scope prefix is scripts body. So this is the scripts body. The scope prefix is store local some lambda blah. So this is the actual lambda itself. Now we're in lambda 1, which is going to be really, I just want to know what the captured is. I think because yeah, so there's no captures yet in this one. That was it. Why? Lookup and capture. We're looking up interface, artifact with accumulator. We add it to the parent captures. Bind the application. Good. So now what do we have here? We should have item 3 is an empty list. Item 3 is okay, so this is the list with the captures. We've done that wrong. So I can see based on the argument array here that this is the outer artifact. And then if I have a look, we'll get the one with N and accumulator, which is where I would expect the captures to be, but it's not. So in the bind, we are adding that into the wrong captures array. So if we're calling lookup and capture, and we're returning the captured value, maybe we need to take the context, call context.parent there, and then add into our captures array. And we should take a context. So here we are again. We've got N, so this is the outer lambda. There is no captures. We've got N again. This is still, this is the artifact. No, that's the assembly name. This is the inner lambda with the captures. Right, that's worked. Let's rerun the test just to make sure I'm not broken anything by redoing the parent lookup there. One exception. Still that new program. Right, so we've got the captures in the right place. What is this? Structure is applied to 4 arguments but expects 3. I think that this has got confused because I had it open in the diff view. I'm going to resave the binder. Yeah. The diff view does not play very well with the F# syntax highlighting. So I think that is, we correctly move the locals from our captured environment if referenced from an inner lambda. And hopefully what should happen now as well is the init effect down here where we actually try and call, we will be looking up the value from the environment. We can just check that. We'll put put a breakpoint in bind ident. Right, so the first time, no. Okay. My breakpoint's not bound properly. Let's edit the breakpoint again. It's probably because we're expecting C# syntax there. The idea is now it affects the accumulator. So what is the context? We have two items in our scope, n, which is argument 0, and artifact, which is in the environment. And we're trying to look it up again. So when we go and look it up after it's been moved from the environment, we should find it. Again, it's the storage reference is a reference to the environment. Good. So effectively what that's meaning is that when we reference the value after it's been moved into the environment, we continue to read and write from the environment, even in the outer scope. Good. Let's just revert that launch JSON change now. So I think that's all the binding work that we need to support correctly capturing things. So I'm going to make a commit there. Bind there's some extra work we could do here, because when we walk up the chain of scopes and we call the parent lookup and we find something, we call lookup and capture, and we find out that we did capture something, we need to add it to the capture chain. We put it into our own captures. We just blindly add it into the captures array, captures list. So what we could do is check here and see if we've got a value in there, but it doesn't matter hugely, and we need to handle the case in the compiler where several different lambdas have captured the same value. So we need to, in the compiler, when we're lowering these values, we need to keep track of what has and hasn't been already moved into the environment anyway. So I don't think I'm going to do anything there. So in the case where we want to move all the values into the captured environment. We want emit lambda to take the captured. All right. So this is effectively the list of things that this lambda has captured, and therefore things that need to be moved into the outer lambda context. So the current context here, the emit context, into its environment. So to do that, we probably we just do trying to work out I think on the context we're going to want to keep track of what has been hoisted already. We can keep this as we could just keep track of what the environment indices are that we've hoisted. So yeah, I'll make it an int list. When we create an environment, we need to handle that by saying hoisted is none. And then in the lambda emit, when we emit named lambda, we create a copy of this outer context. We need to reset what has been hoisted. So what I'm thinking is we will effectively do a map over the list. So we'll do context hoisted. It's going to be list.fold actually. And we're going to fold it with maybe hoist value. If I can spell list right, or capitalize list right, and we need to give it the initial one, which is going to be context.hoisted, and we need to give it the list, which is going to be captured. Okay, maybe hoist value, it's saying it needs to take state and t and return state. So state and which is hoisted, capture is the value that we've captured, and then effectively what we're always going to do is return, well, we can do if list dot If list contains we need to know what we've captured first. If we've captured something into the current environment at the given index from the given location, then we're going to do the hoist. If it was a capture, from somewhere, so I am imagining these environments to work is that there will be a class that contains an array for all of the environment values and then a pointer to the parent environment. So I think the way this will work is we'll just make the environment always have the parent pointer in it. So if the only thing we can actually have captured that needs hoisting is when we've got an environment storage type. All other storage types we can just ignore. So we will return hoisted in that case. And in this case, we will return index with hoisted on the end. Now we need to do list.find if list.contains if the index is already in the list, then we just return the list. Otherwise, we need to perform the hoist. So the way the hoist is going to work is we're going to have to emit a read to this location. Hopefully we can share this code between the load and the store. So we're just going to change this to be context. Should be all we need, right. So if we load from the inner storage location, so that's going to be like either a load arg or a load local or something like that. We then need to write it back to the environment location. And again, you'd hope that this would be as simple as writing so we've already got this. It's this part here where we actually emit the store. We want to extract. Because there's a little bit extra that goes on in up here, because we duplicate the value. We actually evaluate the value first and then duplicate it. So we've got 2 copies on the stack. Take 1 copy and store it back into wherever we wanted. We don't need to do any of that in the hoist case. We actually just want to end up with a balanced stack at the end. Global. So that should be so basically we read from the inner location and write back to the capture location, which is effectively going to do a write to the environment. I'm starting to think it's time to call this a day and have a look at actually emitting an object for our environment in the next stream. Because what we're going to need to do there is, in the compiler, we'll have to keep track of whether or not we've newed up the environment. We're going to have to keep track of how the arguments map onto like, yeah, if we have a lambda, if we're writing out a lambda which needs an environment, we will be writing into an instance method. So the IR will emit for things like loads and stores and things like that will be slightly different. So it's not actually quite as simple as just new up an array somewhere, store it in an argument, and then read and write to it. Because we need to have a way of effectively all of those lambdas that we generate that have captures need to be instance methods on the environment in our outer lambda. And then we need to keep track of that environment somewhere in a local. So we need to keep track of what the local index is for our environment. So there's quite a bit of work to do there. So I'm quite happy with where we are right now. I'm just going to review what we've done in the second part of this stream. So we've added hoisting support. We've got the list of indices that we've already hoisted. We've got load and store now use this read from. And we've got read from and write to. And down in the emit if and okay. In emit lambda, we take the captured list, we iterate through it and hoist any values that haven't already been moved into the environment. We default the hoisted list to the empty list. Right. Emit. Right, thanks for watching and I hope you enjoyed it. I will be back sometime soon with the second part of hoisting. So actually declaring those environment objects and writing some code in our load and store in the read from and write to emit loads and stores from that environment object rather than loading the local values. Thanks.